about Hedfors and his talk owning the data center using Cisco NX-OS. Go ahead, thank you.
So, yeah, there's my details. I don't think I have to introduce myself any more than that. I'm a part of the TOOLCRIP group, which some of you might know about, and working for a company called Cybercom. All right, this is Cisco NX-OS. For first, has anybody here heard of the NX-OS systems or the Nexuses? 1, 2, 3, 4, well, quite a few. That's pretty cool. Do we have any representations from Cisco here today? Well, in that case, I would say sorry, but that's fine. So, I'm going to talk about a short introduction to NX-OS from my perspective, and a bit of a history of what I've been researching, and a review of the underlying. Oops, maybe I should turn that off. Turn off. There we go. There we go. All right. Blah blah blah. And I have a few problems with the Cisco NX-OS system that I'm also going to talk about, and some frequently asked questions, and I'll also do a short demo of some ancient stuff. So, what is NX-OS? From my perspective, it is actually a built-in Monte Vista Linux system based on the 2610 kernel, which we all know is fairly old. But all right, I mean, I suppose they can't update these all the time, so that's fair enough. They look somewhat like this. It's a big ass box with a ton of ports. For all you guys who are working with these, the types of systems are there in the square. The kind of systems that are actually running this operating system, as you can see, is quite a few. So anyway. Last year, I made an accidental discovery of an attack that my friend FX found about 9 years ago, and which then was classified as denial of service attack against, well, most Cisco systems. This was patched, and no one really saw it for a few years until now. And I was a bit surprised about the whole thing when it happened. So I started digging into the whole thing, and I was able to recover core dumps, which is quite interesting. And later on, I went back to look at the Cisco firmware files, and I was able to recover like Linux files from the binaries that Cisco gives you when you download it, or when you want to install some new stuff, and a number of vulnerabilities. What I haven't really looked into is the VDC VRF security stuff, and that's simply because I don't really know Cisco. I'm just a hacker. I'm just a researcher. So if you have any Cisco specific questions, I probably can't answer that. So, the Cisco 7000, which I've been focusing about, is the biggest badass thing you can ever find out when it comes to networking. And you will most likely find these in large environments such as bank finance, core environments. You can pretty much run a whole data center using one of these machines. They go on by default with 512 10 gig switch ports, which is quite a lot when it comes to switching. And as you can imagine, if you're going to invest in a new large data center, you may want to save some money, and you're going to buy this chunk of metal, which is, from my perspective, no more than a chunk of metal. The impacts, however, if you if you own one of these machines, of course you own all the VLANs, obviously. You can probably eavesdrop on everything and modify the traffic on the fly. So, well, yeah, of course, rootkits. I haven't looked into this because, as I said, I'm just a researcher. I'm not here to destroy the world. All right. This is a picture I stole from Cisco. It describes the layout of the system. These two VDCs, or virtual device contexts, as Cisco describes them, is, can I point with this? No? All right. Anyway, these are two virtual switches in the picture, and in theory they should be separated by a layer 1, and all these protocols will then go between the switches as any normal switch. Ah, thank you. Ah, cool. Oops. Yeah, it did. Fucking hell. Yeah. That's -1 though. Anyway, so as you can see, there's a lot of stuff beneath all this switchy thingy, and they forgot to include the Linux thingy, which is in there between. So I just wanted to point out where it is. So if you can imagine, if you own the Linux, you own the whole you own the whole thing, which is bad. So why is my pointer here? Ah, there we go. I wanted to show you a bit of what the underlying Linux looks like when you show it to audience that understands this. So what we have here is what an iOS system would have looked like. I mean, an iOS system is just one kernel with all the services and everything built into it. And as this is a Linux thingy, they've taken all these protocols and all these interpreters and made them into daemons, demonizing everything. And as the devil would say, you should never really use root at every point you can. I mean, none of these daemons are either change rooted or has any kind of other protection. So you can just imagine what would happen if anybody would find like a vulnerability in any of these protocols that any modern switch today has a capability of reading. The impact would be enormous. You would own the whole data center, pretty much. Because there's no other protection than this, whatever it is. So I started looking into what other things can I find. I mean, this was hilarious. I was just laughing. I was like, what the fuck? So I started looking into command line interfaces. And as we all know, this nifty Cisco command line interface you get when you SSH or telnet, God forbid, to a Cisco device. You get this really cool interface where you can tab. It helps you in every way possible. It's very easy. So I found out that this command line interface actually derives from a number of configuration files in the backend. It is quite interesting because no one, as far as we know, has really seen what the magic is all about. So I started looking into this, and I found interesting strings, such as hidden, which I thought was quite interesting. In a few places in these configuration files. Now, we all know that there's a few commands there, but I mean 681 hidden ones? Come on. This is what the configuration files looks like. At the top there, you have the syntax, which is what the interpreter would expect from you. Okay, you would type system, you would type GDB, and there would be an input of some kind. And as we can see, it's an integer between 0 and 65,036. However, the keyword hidden points out that GDB in this context will not show up on any help or on any tab. And unless you can do the exact right statement, it will just say, well, there's no such thing. And to demonstrate that, this is what it looks like from the command line. Which is quite interesting, isn't it? Yes, obscurity. We like obscurity. So, well, GDB, as you might have noticed, is interesting from a hacker perspective. So I poked around with it a bit and found out that you could escape the command line interface using GDB. First of all, this is a normal command in NXOS, as people might know. If you run just show processes, you'll see the Linux processes, which is beneath the whole system. And I was kind of surprised at first because I didn't realize it was a Linux until I started doing this. And I was, these processes look so much like a Red Hat, I don't know. So this is what happens if you type the correct command with, a process ID, for instance. And it opens a port, and you can just, connect and do whatever you like. So what could possibly go wrong? I'm not going to demo this because you can own the whole thing. So I'm just going to show you roughly what you can do. And as we all know, using GDB, you can call on functions compiled into the processes. And hopefully it works. Sometimes it doesn't. Sometimes it does. So as we all know about all these processes are running under root context, if we just call, I don't know, bash, ID, add user, I don't know. There's endless possibilities of destruction here. So that's the first way of actually escaping from the command line interface into the underlying obscurity. So what could happen if you escape? Everything underneath this shell is driven by sudo. Because what you have in your hands when you log on to the Cisco switch, you have the Cisco shell, which invokes Unix commands in some cases, or in many cases. And can anyone here spot the problem in this Pseudoers file? It is here. It says all, no password. So in any case, if you are able to escape from this hank of crap, you can do whatever you like, pretty much. I haven't really dug into these commands because I just don't find it that interesting because you can root this in so many ways that it's just sad. But you can just imagine. I mean, for instance, when you run the system GDB, will start the GDB server under root context and such. Yeah, it's interesting. And also, I've been decompiling the shell to see what it's actually doing in some cases. And this is some scary code that I came across. I mean, you shouldn't really launch stuff using sudo from binaries, should you? And this is not just one occasion, it's many occasions. And as you can probably imagine, there's endless possibilities of destruction when it comes to this type of device. So I figure that everything is running as root. Everyone executes stuff using sudo for obvious reasons. And even binaries do sudo. So I mean, is this even fixable from an architectural standpoint? I mean, they rely solely on using sudo and root stuff for everything. And I've been asking myself this question, is it possible to fix this using a hot fix or a quick fix in some way? I don't know. Personally, I don't think so. I think they have to rethink the whole concept of NXOS in order to secure this in any perspective. Of course, I mean, you can have a you can have really nice users, but you know, that's probably not going to happen. So, moving on, what about layer 2? CDP, Cisco Discovery Protocol, is, as I said previously, FX crafted a denial of service in 2001. Yay. And I found it again, and as we can see here, CDP is now a daemon as of everything else, and is running as root. What could possibly go wrong? Yeah. So this is the cool stuff. I mean, I haven't crafted an exploit for this yet, simply because I suck at assembly. But that's fine, because I don't want to destroy the world. But this is one of the core dumps that I've been able to craft. And as we can see, there is problems. And many of you probably know that this is not that good. And yeah, interesting stuff. This is what actually happens. They've made their own malloc function. Obviously, it must be for a good thing. I don't know. You tell me. But I mean, I suppose if you don't want to do, I mean, memory allocation really fast, maybe you need to make a new one. But I don't know. For obvious reasons, you'll escape all kind of heap protection, but maybe you don't need that. So I've been analyzing this vulnerability, and my conclusions somewhat are that the length header is a 16-bit value, which means it could be pretty big. And this is from the actual X-ray thing. And as we can see that they take the 16-bit value, they make a new byte value, which is 8 bits. And they convert the length from a 16-bit value into an 8-bit value, which concludes truncation. And then they allocate memory using the 8-bit value, and they memcopy using the 16-bit value. So anyway, it's going to break, however you do it. And that's just one of the problems. I mean, I've been studying the code in detail, and I found out that when I was digging around with this, I tried to find out where's my payload. I wanted to see if I can do something cool here, which I couldn't, but I found the payload, because in the code there was a hard-coded pointer, which I didn't understand why, because there was memcopies to and from that hard-coded pointer, which is scary enough. So I looked at that pointer in my core dump, and yeah, there was my content. So they're using some kind of hard allocation thingy. I don't know. It's not really my area. Ta-da. Ooh. Yeah, there we go. Okay, yeah. So that's pretty much what happens when they, if you say I have 1400 bytes, it will allocate 87. And then it says poof. Yeah, boom. So, other funny stuff. In the Linux system, there is a passwd file, as in any other Linux system. It contains the users that can log on to the machine. And the users has to be there in order for a logon to occur. And it also has to be in the Cisco configuration file for the Cisco guy to see that the user is there. And I found this FTP user, which for odd reasons has a password, but it also has a no shell, so it's not possible to use it, as far as I know. I mean, there might be some other attack vectors where you can use this user, but you can't log in using it using SSH. And I haven't really looked into that further than that. And I cracked the password NBV123, and everybody started to Google. This is anyway what the configuration file looks like inside NXOS. And as you see, you have the admin dude, but you don't have the FTP dude. So that's an interesting way of actually backdooring the system. Add the user in just one layer, not the other. I did Google for NBV123. Here it is. There's nothing interesting. The most interesting I could find was that it was an example on how to make your own snake oil certificates, and the example password they had was NBV123 for some odd reason, so I don't really know where it comes from. But it looks like someone may have read an example of doing something, and NBV123 was the obvious password. So, does anyone know what this stands for? Yeah, if anybody hasn't played Doom here, you should lay down on the floor. It means God mode. Yeah, I found God mode in the Cisco. Not using IDDQD, but using the shell itself. This is the shell that starts when you log on as a normal user to the Cisco device. This is all the parameters you can supply to it from the command line. So, in example, you're able to escape the command line as a dumb user. You don't have really admin permissions, but you can still escape the command line. So you're inside the Linux, but you just have a normal user, but you don't really care about the Linux because you really want to own the router from the router perspective. How do you do that? First of all, you could jump into any virtual device context as you like. Or you could just skip all the rules. And that's your God mode. I've been querying Google about this endless possibilities of destruction and evilness. And they say that this is a feature that they need. So I don't think they're going to do away with it because they need it. It's a feature. For those who knows NXOS, you know that you can switch between VDCs if you're an admin. And I guess that what they actually do in the background is launch another shell with the ID of the context you want to go into. That's what I guess. So I guess they need it. But from my perspective, it should be done in some other way. So I told you I want to show you some ancient stuff, and when I found these vulnerabilities, I was looking around to see if there was a DeLorean around, because I felt like I'm back from the future or something. Oops, here we go. Ta-da! NXOS. I actually have an NXOS in my VMware, simply because there is a VMware version of NXOS. Ta-da! So it's not real magic. Anybody can download it from cisco.com. It's called V1000, V1000, and it comes with a 60-day trial license for anybody who wants to poke around with the system. So, back to the future. Here we are. System. Yeah. Well, we're in the Cisco system anyway. So one thing I tried one really early morning when I was hungover and didn't really know what I was doing. I was just poking around with it, and I found out that you can do something like this. Ta-da! Ta. Back from the future. I mean, I tried to, for these presentations, I tried to find references to when the Backtick vulnerability was first discovered. And the first reference I found was from 1991, I think. And yeah, I've been fuzzing around with this stuff, and I found maybe 5 or 6 different places where you can do this. And that's simply because in the configuration files, they do some kind of input validation, but they have a kind of input that states like anything, and that's what they use here. And as we all know, SSH is then invoked from the Linux perspective, so they just shove everything into the backend. And yeah, glory. Ta-da. So, for those of you who are interested in bug tracking, there's a few bugs you might be interested in tracking, and these are those. There's actually quite a few more, but these are the most interesting ones when it comes to, I mean, total annihilation and compromise. And I'm also thanking Juan Miguel Gonzalez from the PSR IT team at Cisco, because he's been very helpful. He calls me on occasions to see if everything is all right, if I have released anything yet. And once I threatened to release everything because he didn't answer his emails. And then the day after he called me and, oh. So yeah, I take questions. As I said, I'm not a Cisco expert, so I don't really know anything about the system except that it's broken.
Did you check if the no bash is actually not a shell?
Yes, I've actually had that question at a different conference. And we had to check it because I hadn't checked it at the point, so I had to go in and see. But there's nothing there, unfortunately. I even tried, I mean, I even tried to supply my own shell to the SSH as you can do, or your own commands, but that doesn't really work. However, there is some really nifty stuff. If you're interested, I can show you. Wrong way. Here we go. Whoops. I'm just going to exit from this crap. This is the Linux. Ta-da. There we go. This is actually the shell which is being executed when you log on as a normal user. It's a script. Okay? And it gets kind of complicated when you start looking at it. I've been trying to exploit this, but I can't really do it. The only thing I've been able to do is run that as a shell, but nothing else. But you know, it looks really messed up from my perspective.
Any stats on how many of these are out there in the wild?
As far as I know, I'm from Sweden. We have maybe 6 or 7 of them in the country because they're so fucking huge. I mean, you need to have like a really, really large data center to have one of these. And where I found this was actually at a customer of mine who's one of the bigger banks in Sweden who was rebuilding their whole internet banking environment. So I have no idea.
Cloud providers might have something like this?
Probably. And I mean, you buy these big pieces of metal for about 150,000 euros. And yeah.
Anybody in the room who has deployed stuff like this? Is willing to
Couple. Yeah. So what are you guys going to do about it? Watch it. Really, really careful.
You know that you can ask Cisco for the source code of it?
Can I?
Yeah, you can. Actually, with the ASA, you can do the same because it's a Linux system. What's in the kernel, what they changed there, they have to...
Right.
So normally on the support page of the Linux product, there's an email, open source ASA or open source NXOS at blah, cisco.com. You have to email them.
Right.
So that could be maybe an easier way to...
I'll probably do that. I haven't really thought about it because I'm not really into this whole licensing here and there. That's a cool idea.
Any other questions? No.
Yeah, back there.
No.
So beside of the CDP bug, are there any remotely exploitable stuff? Because for all your attacks, you need an actual local user on the router, right?
Exactly. I haven't really fussed through all the daemons, and that's just because I'm lazy, and because I don't want to destroy the world. But I mean, as I said before, the whole yeah. I mean, the whole architecture is broken anyway. What are you going to do about it? I mean, you're gonna find hundreds of problems in this. I've literally used maybe 20 hours to find this stuff. And I've only like Sunday mornings really hangover, like poking around. It's like, oops, here's not a bug.
More questions? No? Good. Then thank you very much.
Thank you.